In this class, we'll focus on redirecting standard input and output. And this is kind of needed for all the execution of the homeworks this week and the future week. So it's kind of a brief but important skill to acquire. So first of all, I'll create a new Visual Studio solution. So let's go through kind of new project. So let's, just to be clear, make sure that I copy the directory where I want the project to be. And so I create an empty project. So here, even if it's redundant, let me write precisely what I'm planning to. So we select this folder, project, input, output, stream test. So we create this project. So here you see it's kind of empty in the sense it has only the structure, but there is no source file. Actually, maybe. Okay, so first of all, we create, we add a source file there. I just rename it and so on. And so now we have a project with a single C++ file, and we need to start working with a very simple input and out stream management. So I'll take this piece of code that is going to be provided in the material for this week, just to proceed quickly. I'm kind of slow at typing on the fly. And so here you see there is a project. So here we have the preliminary input stream, input output stream, and string. So those are library needed for the execution of the various components. Here we declare an integer value variable initialized as 0, but later on we'll read from standard input the number, and then we print the number out there. And then we allocate 4 variables of type string, word 1 to 4, and then read them and then print them out. Notice that at this point, the initial number and the number of words that we read are not connected to each other. And so this kind of keeps the code a little bit simpler. So let's first of all compile the program. So the program is succeed. Just to give you a sense, for example, if I forgot to put a semicolon here, the build would have failed. You see 0 succeed, 1 fail. Double click here, it would bring me right after the error. So this line is okay, but then I go back a little bit and realize that the semicolon is missing, and so we build this. So now we can execute. Again, we'll read a variable and print 4 strings. Let's run the code. And so let's say I type number 5, and then I just put a bunch of strings kind of randomly. Notice that there was an empty line with no string, so that was skipped and didn't get to the final point. And so word 1, word 2, word 3, and word 4, and then the number is 5. So it's kind of very simple here. Now this was done manually. So as you can imagine, it's kind of really hard was to every time type things manually, because if you have to debug over and over or get longer, I don't know, if I want to test 50 50 words to make sure that I include all possible cases. It's kind of tedious and also get lost, right? Once it's finished, things are not there anymore. So what we want to do is first we want to redirect the input and output into the file system of the computer directly, so that the manual typing doesn't have to happen. So normally, so this is, for example, where the executable of the code is. This is kind of the main folder of the solution is. This where the solution is actually being created. And so let's say that we don't feel entirely confident where this will locate it. So first of all, we redirect just the output. So we will type the input manually. So here we go to the solution, look at properties. So under debugging, you look at command, basically command line arguments. And so if you do greater than, and then yes, we have the output .txt, it means that instead of printing on the screen, the output will go into that particular file. And we will figure out where the file is going to be located, right? There are a few directories where we can look at. And instead of saying it will always go in a particular location, because again, many of those things depend on the configuration, this is a simple way to actually find out where things will point to. So let's say I do my usual variable, and now I do my 4 words. You see that there was no output, but so here there is no additional file. And this is here the file output.txt that actually has the output that was needed and so on. So here we have figured out that the directory where those variables will go is located in the top folder. Again, that could be changed. They can go inside debug, or if you compile in the solution optimized mode, you have the other folder. Again, instead of remembering, you have a simple way to figure that out. So now let's copy an possible input file. Let me see. So this is the content, number 8, and then a sequence of words, Valerio, Pavel, and so on and so forth. And so let's put this file in the same directory. So this was where output is created. And so here we have the input file. So what we want to do is go in the solution. Again, look at the properties. And here, say smaller than, we put the name of the other file. So it will read everything from here and put it in the other, which means we don't have to do anything manually. Okay, so for example, when I do now execute things, as long as there are no error, nothing gets blocked here. And now the input was this file that I just showed, and the output, you see, after replacing that file, the output now, so again, this is the input, 8 with a bunch of words. And so the output is numbers 8, and then Valerio, Pavel, Venkat, and Anaconda. So those are the first 1, 2, 3, 4 words in that file. And that corresponds to the structure here. We read a number, and then we print 4 words irrespective of that number. Now, if we want to improve this a little bit, and let's say we want to type the initial number, but then we read exactly the number of words that are required from the input. So let's follow a little bit the structure of this code, we have still the variable, the number. We read that variable in the standard input, and then we print it. So this part of the code does not change. Now, instead of reading a fixed number of words, we now allocate a single string variable. And then we create a loop with a for statement. So we have a variable I that goes from 0 to the number, excluding this. So it will have to be smaller this. And since we start from 0, so from 0 to 4 are 5 iteration. This is the short command for, say, increment I. So you have from 0 up to smaller than the number, and each iteration you add 1. And then we read a word, and then we print the word. So instead of first reading all the words and then printing all the words, we read one by one, read, write, alternating, and so on. And notice that the read happens from one file and the write happens on the other file. So let's clear all the annotations. And so now we can execute this piece of code. Oh, let's see, there were errors here. Let's identify the error, something behavior here. Oops, we forgot a semicolon, which also, I guess, is the reason why the indentation from the 4 was that far back. So this should have been a giveaway of the error it was in the code. So let's try and build again. 1 succeeded, 0 failed. So at this point, the code, at least from the perspective of the syntax, is correct. And so now again, we're running with this. So it should read 8 words out of this. Notice that those are 10 words, so it should read the first 8 out of the sequence of 10. So let's just keep it like this. So we run the code. Everything seems to execute it fine. And then we look at output. We reload that output. So this is Notepad++ is kind of nice to notice that the file was modified. So notice that every time we rewrite output. And so now the number is 8, word 0, 1, 2, 3, 4, up to 7. And so this second variation allows us to give an input, how many words you want to read, and then we'll just print them out in sequence. I hope this kind of practical overview will make it obvious. I'll show how to pinpoint where the location of the files is and so on. And so this, for every exercise, we always expect the inputs to be given from a file like this. We always recommend that in addition to the inputs that we provide, create your own input. So because we will not test the code only for the example that we provide. So for example, if the test case that we provide is this, you might want to create another one that has, I don't know, 20 or 2